Welcome. This presentation is a comprehensive guide to HDFS maintenance and upgrade best practices. We will walk through a structured strategy for keeping your Hadoop distributed file system robust, secure, and performant. Managing a distributed system like HDFS requires a meticulous approach to maintenance and upgrades to ensure data integrity and high availability. Let's begin by outlining our overall strategy. Our strategy is built on a foundation of careful planning and coordination. The core principle is to balance cluster availability with essential operational requirements. We do not perform critical operations blindly. Instead, we employ a structured approach that includes thorough risk assessment, detailed impact analysis, and well-defined rollback strategies. This proactive mindset is crucial for minimizing disruption to downstream users and applications. Strategic planning is the critical first step. Every maintenance activity or upgrade must be preceded by careful coordination across teams. You must answer key questions. What is the business impact? What are the dependencies? The goal is to always balance cluster availability with operational requirements. This structured approach mandates three key elements. First, a formal risk assessment to identify potential pitfalls. Second, an impact analysis to understand the effect on jobs and services. And third, predefined rollback strategies to ensure you can quickly revert if something goes wrong. To minimize impact, always perform non-emergency operations during scheduled maintenance windows. These are pre-communicated periods of planned downtime agreed upon with all stakeholders. This practice is especially critical for major upgrades or large-scale hardware replacements. Using consistent windows helps manage user expectations and allows you to batch changes, reducing the total number of disruptions throughout the year. Never test in production. Always validate all maintenance procedures in a staging environment first. This environment should mirror your production setup as closely as possible. By testing here, you can identify and resolve configuration issues, software bugs, and performance regressions before they affect your live data and users. This practice is your most effective shield against unexpected failures during production rollout. For large clusters, manual maintenance is error-prone and inefficient. Embrace an automation approach. Script your common maintenance operations, such as decommissioning nodes or applying configurations. Leverage management API and frameworks like Apache, Ambari, or Ansible to ensure consistency and repeatability across all nodes. Automation significantly reduces human error, enforces desired state, and saves valuable operator time. HDFS provides built-in tools to simplify maintenance. Introduced in CDH 5.11, the HDFS Maintenance State feature allows you to gracefully take data nodes or even specific disks out of service. This tells the name node to stop replicating blocks from these nodes, avoiding unnecessary network overhead and re-replication storms. Key configurations include setting dfs.namenode.maintenance.replication.min to a value like 1. For management, use the JSON-based combined host file with the combined host file manager. You can also set a maintenance expiration time using maintenance expired time in MS to automatically return nodes to service, acting as a safety net. Operating system maintenance, including kernel updates and security patching, must be performed in a rolling fashion. Update one host at a time, and always coordinate with ecosystem components. For instance, if you are running HBase or Yarn, ensure you drain roles or put region servers in a draining state before rebooting a host. After any OS update, verify that critical kernel parameters like VM, swappiness, and transparent huge pages are still set correctly. When applying security patches in a Kubernetes environment, coordinate to ensure ticket validity and service principal functionality after reboots. Upgrading HDFS itself requires a meticulous procedure. First, assess upgrade readiness, check compatibility matrices, read release notes for known issues, and ensure you have verified backups. The recommended method is a rolling upgrade. Start by preparing the upgrade with the command HDFS dfsadmin rolling upgrade prepare. Then upgrade components in this exact sequence: general nodes first, then name nodes in standby mode, followed by the active name node, and finally, all data nodes in a rolling fashion. After everything is upgraded and stable, finalize the upgrade with HDFS dfsadmin rolling upgrade finalized to make the changes permanent. Maintenance windows are a perfect opportunity for performance optimization. Consider tuning your block size. 128 megabytes or 256 megabytes are common depending on your workload. Review and adjust replication factors based on data criticality to optimize storage. Leverage Yarn for data locality to process data where it is stored. And finally, apply appropriate compression algorithms like Snappy for fast compression, LZ4 for a balance of speed and ratio, or gzip for maximum storage savings on colder data. After any maintenance, rigorous validation is key. Implement advanced monitoring tools like Excel data for deep visibility into cluster health. Conduct post-maintenance checks. Run HDFS FSEK to check file system health, verify block integrity, and validate that key workflows execute successfully. Crucially, maintain detailed runbooks for every procedure. These should document every step, rollback instructions, known issues, and vendor-specific notes. Furthermore, use maintenance windows to gather metrics for future capacity planning. In conclusion, we recommend establishing a proactive, rather than reactive, maintenance culture. Always balance risk, apply patches, and upgrades selectively based on need, not just availability. Remember, HDFS does not exist in a vacuum. Coordinate its maintenance with all ecosystem components like Yarn, Hive, and HBase. And finally, use specialized monitoring and automation tools to gain deeper insights and operate more efficiently. Thank you. To help you categorize and plan your activities, here's a maintenance classification framework. For OS security patching, use tools like Embari or Ansible. Downtime is typically minutes per node, and the risk is generally low. An HDFS version upgrade using a rolling upgrade requires no downtime and carries a medium risk due to its complexity. A hardware refresh, which involves decommissioning old nodes and commissioning new ones, can take hours to days of downtime and carries a high risk. Finally, rack maintenance, utilizing the HDFS Maintenance State, requires no downtime and presents a low to medium risk. Use this framework to communicate plans and set expectations with your stakeholders.